Okay, so kita sambung lagi ke next slide, which is shear reinforcement. Okay, shear reinforcement may arise in several ways, but two principal failure mechanisms are shown in figure. So not only the beam is subjected to bending stress, also dia subjected to shear stress. Sebab you pun pernah belajar dalam masa part tu, kita ada belajar macam mana nak plot that diagram yang show the bending stress and shear stress, especially in beams. Jadi, because this is the two stresses that mostly affected beam. Okay. Kalau column tu mostly kebanyakannya compression. So depends on what kind of elements yang you tengah calculate. So for beam, shear and also bending stress. Okay, so in order to resist bending stress, we need to put shear reinforcement also. Okay, not only satu. Allahu Akbar. Pen. I need to select the color. Okay, not only we need to resist bending. So bending reinforcement sebenarnya, okay, yang bawah ni kita panggil dia juga as bending reinforcement. Bukan saja kita panggil dia main bar, main reinforcement, kita panggil dia bending reinforcement because it actually act to resist bending stress. Okay, and then what we also need to design for shear reinforcement. Yang the one yang keliling ataupun kita panggil dia link. Okay, so shear reinforcement we also call it as link. Okay, so bending reinforcement yang sebelum ni kita belajar, yang you kira AS, area, that thing, itu semua kita panggil dia as mungkin bending reinforcement, main bar, main reinforcement. So benda yang sama It's actually the same thing. Okay, for shear reinforcement it is link. Okay, shear reinforcement ada principle dia ada two failure mechanism. One of it, tengok sini, diagonal tension and also diagonal compression. Okay, what does it mean by diagonal tension? Loading increase and incline crack rapidly develops between the edge of the support. So here we have support. Support ni mungkin column ataupun wall, shear wall that can support load bearing wall that can support load from above daripada beam you ni. Okay, definitely there will be force that going upward because kita belajar equilibrium kan, whatever goes down must go up, so baru balance. So this force yang kita calculate ni in a state of equilibrium. Kalau you masih ingat part 1 you belajar about equilibrium and such. To make things balance, so mesti ada equilibrium. Okay. Apa cerita sini? Crack rapidly develop between the edge of the support and the load point. So when we have here load from above and support from below, this will cause the beam untuk crack dekat this area. Okay, when it crack, it resulting in splitting of beam into two pieces. So that's the reason why we need the shear reinforcement. Okay, to avoid beam from splitting into two. Okay, because ini ada load daripada atas, force daripada bawah yang akan support dia akan menyebabkan beam ni crack, pecah lah. So bila kita pasang reinforcement, maksudnya pasang this shear reinforcement, dia actually can help to prevent cracking from happen. Okay, the other one is diagonal compression. Okay, this is occur under the action of large shear forces acting near the support. Okay, large shear forces that come from above. Aduh, semak lah. Contengan banyak sangat. Okay. Large shear forces that coming from above, okay, resulting in crushing of concrete. Because of these forces is too much, okay, what happen is you will have a material failure. Okay, means that mungkin concrete you not strong enough to resist the load that come from above, so materialnya akan crush. Okay, can be avoided by limiting the maximum shear stress to 5 Newton over mm square or 0.8 FCU. Okay, so this is the limit that provided by the BS, the standard. Nanti bila you belajar, after this you akan belajar macam mana nak design shear reinforcement. So akan ada clause yang menyatakan you kena limitkan maximum shear stress untuk maksimum dia takkan lebih dari 5 lah. So maksimum ni 5 tak boleh lebih dari 5 Newton ataupun 0.8 FCU, whichever is the lesser. So contohnya kalau FCU you 30, okay, FCU ni kita dah tahu kan, which is the strength of the concrete. So katakanlah FCU 30, so 30 darab 8, salah, betul. Okay, 30 darab 8. So I rasa salah ni, 30, I rasa formula ni, kenapa formula ni macam lari? Kejap I check balik formula. Okay, betul lah, formula ni salah sebenarnya sebab dia kehilangan power of 2. Okay, formula ni supposedly is 0.8 square root FCU. Okay, so 30 square root. Okay, and then you darab 8. You akan dapat 43. Okay, so compare 43. Salah. Square root 30. Okay, darab 0.8. Okay, you akan dapat 4.381. Compare 4.381 dengan 5. So 4.381 lesser than 5. We're going to choose 4.831 lah to compare. Meaning bila you kira forces that come from above, meaning the stress that is coming from top here, it cannot more than 4.381. Okay, kalau lebih maksudnya akan jadilah diagonal compression. Okay, that's why ada this kind of clause. Never mind, mungkin tak faham, kita boleh proceed lagi, nanti kita kira baru kita faham kot. Okay, alright, here we have shear reinforcement, the formula. Okay, why we need to calculate all these things? Because we need to find what we call it, macam mana kita nak design shear reinforcement lah. Okay, so kita kena calculate, proceed lagi sampai shear reinforcement normally. Okay, so here I ada betulkan sikit formula sebab tadi tak ada formula depan ni, yang depan ni. Okay, to calculate shear reinforcement, you need to calculate the design shear stress at a cross section. Meaning meaning when you have a cross section of beam, yang the area yang you cut tu lah, dekat mana tu, so kat itulah cross section dia. Contohnya macam ini, and you already know that for beam the cross section is mark lah dalam ni. Mana aku nak alih kan, tak nak pula dia beralih. Okay, cross section of beam contohnya macam ni lah. Okay, you potong kan beam tu, so kat mana area dia, sepanjang-panjang ni, so area dia, so kalau you potong kat sini, so cross section ni kat sini lah. Okay, kat di area ni, okay, we need to know the design shear stress at cross section. So berapa cross section ni? So maksudnya sekarang ni, the one yang you tengok from previous slide, okay, yang dekat sini yang we talk about the maximum shear stress 5 Newton over mm square or 0.8 FCU. This is value ni yang kita akan compare dengan maximum shear stress ni. Okay, sama ada yang ni atau yang ni kita nak compare. So value yang akan kita calculate dekat sini. Okay, berapa design shear stress at cross section, compare dengan this value to make sure that second failure mode ni tak terjadilah. Okay, itu adalah one of it. Okay, why we need to have this design shear stress. To calculate the design shear stress, the formula is shear force. Okay, berapa shear force on top of the cross section yang you kira tu. Sebelum ni I dah bagi tahu for beam it is normally adalah UDL ataupun uniformly distributed load. But we need at the section ni, sebab uniformly kan dia sama je, tapi dekat section ni berapa? Maksudnya katakan 5 kilonewton per meter contohnya lah. Okay, and then divide by B darab dengan D. Okay, B ni adalah breadth and D is effective depth. So you dah tahu apa B, apa D dalam sebelum ni I dah explain dalam this one. Okay, dah nampak where is B and where is D. Okay, the effective depth and also breadth. Okay, that is the formula. Okay, in order to determine whether shear reinforcement is required, it is necessary to calculate design concrete shear stress VC at critical section along the beam. The design concrete shear stress VC can be determined using table 3.8. Okay, we need to know, okay, kat mana critical section, okay, macam mana kita nak dapatkan VC. Okay, maksudnya critical section punya concrete shear stress. Okay, kenapa kita nak tahu? Sebab okay, reinforced concrete beam dia ada konkrit dan besi. Okay, reinforcement. Okay, kita nak tahu sejauh mana konkrit tu boleh resist shear. Berapa banyak. Okay, yang selebihnya kita kena pass dekat reinforcement. So that's why kita nak tahu maximum yang concrete can resist shear so that the balance can be resist by reinforcement. So that is the reason why. Walaupun kita tahu yang reinforced concrete tu tak boleh resist shear so much blah blah blah, but yeah, it is not so much, but dia ada property to resist shearing. Okay, shear force. Okay, how to calculate this? Okay, so you see here we have formula. Okay, 0. Apa panjang ni formula ni? Okay, this is a little bit confusing. Okay, macam mana cara kita nak kira, but I need to simplify this formula for a while. Okay, I dah tulis 0.79. Okay, VC ni maksudnya design concrete shear stress. Okay, design concrete shear stress maksudnya concrete stress, concrete ni boleh resist berapa banyak stress. 0.79 darab 100 AS divide by BD punca kuasa 3. Okay, darab dengan 400 bahagi dengan D punca kuasa 4 divide by unit weight. Bukan unit weight ni, apa nama benda lah ni? Alah, I pun lupa lah apa kita panggil benda ni. Okay, M. Okay, M ni berapa value dia? Okay, it is 1.25 given. So dia apa orang panggil, bukan static, constant lah. Okay, 1.25. Okay, so itu adalah formula dia. This is quite hectic punya formula. Sebenarnya daripada formula ni you boleh dapat daripada this table. Okay, dari formula ni sebenarnya kalau katakan you already have the effective depth, maksudnya effective depth you constant, contohnya 250, 300, 400. Okay, and then you dah kira 100 AS BVD ni, 100 AS divide by BD yang macam yang ni. Okay, you dah kira, you cari dekat sini, you boleh terus tengok dalam table. But it is slightly not orang panggil precise lah, because of kadang-kadang kita punya effective depth tak ikut macam atas ni, bukan 200, bukan 250, bukan 250, mungkin kita punya effective depth 275 tapi tak ada dalam table. So it's going to be hard for us macam mana kita nak tengok dari table ni. That's why we do the formula instead. So this is the formula, quite complicated. It's actually from this one yang I tulis dalam bentuk, although my handwriting quite ugly, but as long as you can understand. So this is the formula that you can use lah. Okay. Okay, enough about that. When we know the value of design concrete shear stress, kita dah tahu apa itu design concrete shear stress. What we need to do is kita kena comparekan pula design concrete shear stress yang kita dapat tadi dengan design shear stress at cross section, which is this one. Okay, yang ni lah, the one that we calculate earlier. V kita akan comparekan dengan VC. Okay, how we going to do that? Okay, because kenapa kita nak tahu jenis macam mana kita nak design dia, whether reinforcement tu akan concentrated dekat satu area ke, ataupun kita nak design dia in a different way. Tak semestinya dalam you punya beam ni, okay, reinforcement tu akan sama. Maksud saya sama, okay, you ada bar, okay, and then you have the shear reinforcement. Spacing ni tak sama, okay. Sometimes near dekat area support, maksudnya dekat column, for example here, this is the end of the beam, so you have column here that support the load from the beam. Here is the critical area. So perhaps there is a possibility that the reinforcement provided at this particular area akan lebih concentrated, maksudnya lebih rapat-rapat lah. Okay, dia punya keliling-keliling tu lebih rapat, dekat tengah-tengah ni berjarak-jarak. Okay, ada possibility for that. That's why kita kena tahulah which type yang kita nak guna. Okay. Alright. So shear reinforcement should be provided, okay, in beams according to criteria given in table 3.7. 3.7 tu mana table 3.7? This one. Okay, this is table 3.7. So here I simplified lah. This one come from BS. When V less than 0.5 VC. So bila you dah kira V, here is V, you dah dapat value of V. Okay, you akan kira VC, you dapat VC, you akan compare V less than 0.5 VC. No shear reinforcement when necessary, although in practice it is normal to provide nominal links in the all beams of structural importance. Okay, tak penting. Maksudnya dia mungkin tak ada resist shear, it just that kenapa kita letak reinforcement tu, because shear reinforcement maksud saya, because kita nak ikat kita punya bar kat bawah ni. Okay, kalau tak bar bawah ni bukan floating, maksudnya tak ada benda yang akan ikat dia. So it's not really important structurally, but it just for the sake of to ikat the bar. Okay, or when 0.5 VC, okay, V ni mungkin lebih besar, so bila you dapat ni lebih kecil, so tak penting lah. Okay, but bila dia lebih besar daripada 0.5 VC tapi less than VC plus 0.4, nominal link based on, so macam mana you nak kira, you are basing on this formula. Okay, you pun boleh tengok dekat sini. Minimum link on whole length of beam. Okay, and then there's another one that might be bila this one less than VC plus 0.4, but there is another condition where VC plus 0.4 tapi dia V lebih besar daripada this value, tapi dia lebih rendah daripada yang limit kita tadi. Ingat kita ada cakap pasal limit, kalau tak dia akan kena diagonal compression. So dia lebih rendah, meaning links combined with band up bar not more than 50%, blah 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 blah. So there is a lot of conditions here. Macam mana cara kita nak kira? Okay. Macam mana kita nak kira conditions kita tu? Bila you dah dapat what conditions that you are in, for example, katakan you dapat yang the one in the middle here, which is V yang you calculate earlier, perhaps it is bigger than 0.5 VC but less than VC plus 0.4. So that's mean that we need to provide nominal link based on this formula. Okay. So based on this formula, it is said that ASV ni maksudnya area of apa kita panggil? Area of shear reinforcement. ASV ni adalah area of shear reinforcement equal to BV minus VC divided by 0.87 FYV. So FYV, bila you nampak perkataan VVV ni, maksudnya adalah dia masih lagi steel strength, sebab FY adalah steel strength, but V at the end of this one is referring to link ataupun shear reinforcement punya steel strength. Okay, kalau you tengok dia tulis FY saja, so FY tu adalah shear reinforcement, bending reinforcement ataupun main bar. Okay, tapi bila dia tulis FYV, so apa VV kat belakang ni, semua ni refer pada shear reinforcement atau link. Okay, so you use this formula untuk dapatkan steel area. Okay, tu function dia. Alright, so apa lagi saya cerita? Okay, daripada value yang you dapat tadi, okay, contohnya you dah kira lah. Okay, you will get some value. For example, I bagi kat sini 0.552. Okay, dah dapat this kind of value. Okay, so bila you dapat 0.552, okay, ASV here sebenarnya refer pada area. But SV at the back here sebenarnya dia dah divide dengan something lah. So bila dia dah divide, so value dia rendah. Tapi ASV is the actual area dia. But from the table, we need to compare dengan ASV divided by SV. So that's why the formula ada SV divided by SV kat bawah ni. Okay. Wait. So we're going to see that konon-konon kita dapat 0.552. So perhaps mana satu kita boleh pilih. So kita kena pilih value yang lebih tinggi. Okay. So for example, it is already given that maybe you kena pakai diameter 10 atau diameter 12, tak kisahlah berapa-berapa diameter But we need to look at to make sure that the value that we have here, okay, value yang you pilih dalam ni mesti lebih besar daripada value ini. Perhaps I can pilih this one, 0.571, lebih besar daripada 0.552 and the one that you calculate from ASV divided by SV. Okay, so you pilih benda ni. Okay, macam mana cara you nak tulis? Because you know that normally for links, kita akan pakai mild steel ataupun mild steel lah. Okay, yang jenis yang smooth face steel tu. Okay, yang the one yang ada R tu. Okay, R, mild steel, kita tahu ala R. So for example here, it is R10 sebab kita pakai size 10. Okay, when we know, okay, normally for spacing kita tak peduli berapa biji, kita tak akan ambil tahu biji, tapi yang penting adalah spacing. Maksudnya spacing in between bar pula dah, in between the one yang kita bend dia untuk jadi round tu. So in between this one berapa sebenarnya spacing dia. So R10 275. Okay, ini adalah spacing size mild steel. Okay, kita dah tahu. Okay, this is how we write it lah. And normally kita akan tambah CC at the back, which is center to center. Okay, this is how we write it dalam drawing. Okay, biasanya dalam drawing lah, kita tak nak lebih panjang. Okay, this is how it. Macam yang kita buat Okay, so I nak stop class here because I rasa next kelas baru I sambung on how to calculate, masuk example 1. Okay, baru kita akan faham. Okay, thank you everyone. Bye.